Are we ready? Okay, so now let's look at our first sequence. Now it's 1, 5, 25, 125, 625. So to get from 1 to 5, you could add 4, but that wouldn't get you to the next one, would it? So they chose to multiply by 5. Now, arithmetic sequences yesterday we were adding or subtracting. Geometric sequences, what do you think we're going to be doing? Multiplying or dividing. Take a point. So, what you do is you take your second term and you divide it by the first term, or your third term and divide it by the second term. You can take any of your terms and divide them by the previous one, and that's going to get you what your common ratio is. Yesterday we had a common difference. Today we have a common ratio because it is multiplication and division. Get super, super excited. Pardon?
Where did you divide?
I did 5 divided by 1, 25 divided by 5, 125 divided by 25, and those all gave me 5. I took my numbers. Okay, well, you're making a face like you have no idea what I'm talking about. Okay, so a geometric sequence has a common ratio. It has a common ratio. So instead of a common difference, it's a common ratio because we are dividing to find it. Now, it also has a rule. So when you're looking for the nth term or any term, you use a sub n equals the first term times the ratio to the n minus 1. So we're going to use exponents on this one. Pardon? An exponent, n minus 1? Yeah, that's why it's tiny and up top. So you take your first term, you multiply it by your ratio once you've raised it to the power of n minus 1. N is the term you're trying to find. A sub 1 is the first term. R is the common ratio. Is everybody with me?
So would you do n minus 1 first, n right?
Yes, you would. Order of operations with those parentheses. Are we ready? Now, example 4 says to tell whether each sequence is geometric. If it is, state the common ratio and write the next term in the sequence. So, all you have to do is divide. So let's do 8 divided by 2. Tell me what you get. 4. Okay. What is, so that you divided and we got 4. What's 32 divided by 8? 4. What's 128 divided by 32? Are you sure? Or did you just guess that hoping that it was the same?
I'm sure.
You're sure? You have all the confidence? Good. 4. So is this a geometric sequence?
Yes.
Yes, it is. So we write yes. What is our common ratio? 4. And what would our next term be?
512.
How did you get 512?
Multiplied by 4.
You multiplied by 4. Fantastic. So you would take 128 and you would multiply it by 4 and you'd get 512. Any questions? Easy peasy? Okay, let's look at the second one. Do you think that this is going to be a geometric sequence? Why? It goes up by 3, then it goes up by 5, then it goes up by 7, and then it goes up by 9. But that's not the same thing every time, right? And if you divided, 4 divided by 1 is 4, but 9 divided by 4 is not 4. So this is not a geometric sequence. What about the next one? This is a good one. Why do you say yes? It's not by 3. Yeah, they are factors of 3, but the common ratio is not 3. What is 27 divided by 81? 0.33333. What is 9 divided by 27? 0.33333. Okay, listen to how I'm telling you to divide. You take the second term and you divide it by the first. You take the third and divide it by the second. So don't just do big number divided by smaller. You have to actually do it in the correct order. So what is 0.333333 in fraction form? 1/3. So this is a geometric sequence. And the common ratio this time is 1/3. We did 27 divided by 81, we did 9 divided by 27, and we did 3 divided by 9, and we got 1/3. So now, what if, do 3 times a third, and tell me what your next one should be.
1.
Do we all agree with 1?
Yes.
Fantastic. Both of y'all take a point. See, no, Troy, you did not say 1. You do not get a point. You can lose a point for lying. All right, try D without me.
Yes.
Remember, you're just dividing. What did you get, Jarek?
Did do negative become like? Cause I got negative.
Yep.
So no.
Mm,
That's why I said does it come to like?
you can have a negative as your ratio.
Like as in like
15 divided by negative 5.
is it yeah and then it's negative 3 again.
And then negative 45 divided by 15 is also negative 3.
Oh, I think.
Yeah. Don't drop the sign. Is it a geometric sequence?
Yes.
Yes. What is our common ratio? And what would the next term be? What's negative 405 times negative 3?
1,215.
Yes. Questions, comments, gripes, complaints? Yes. I'm sorry? This one? This one? I took this and multiplied it by my ratio. Yes.
How did, like, I know you said sometimes these things, like, go, I guess, backwards, like, sometimes you could say 15 last time you tried.
Every time you go backwards. Every time, yep. You would do 15 divided by negative 5, negative 45 divided by 15, 135 divided by negative 5. Every time you go backwards.
Okay, the first I did, I did -5, not 9, but 5.
And that gave you a third, which would not get you to the next number, yeah. Any other questions? Yes, no, maybe so? Okay, now, the graph of an arithmetic sequence was what kind of line, or what kind of graph? Linear. Yeah, good. Take a point. So the graph of a geometric sequence, because it has an exponent, is going to be an exponential function. Now, we graph it the same way we did yesterday. So this is the first term, this is the second term, this is the third term, this is the fourth term. So this is our x, this is our y. Yep, the number up top is our x, and yes, we go right 1, up 1. Now, how would we get to 2, 2?
Right 2 and up 2.
Okay, how would we get to 3, 4?
Right 4 and up 3.
Right 3, up 4. And how would we get to 4, 8?
Right 4 up 8. Right 4 up 8.
Now, that's not linear, is it?
No.
That is an exponential function. So the graphs of a geometric sequence are exponential functions. Yes, no, maybe so. Anybody have any questions? Okay, so on the bottom, we're going to practice writing the rule, and then we're going to plug in and practice finding the next number. So, remember, when we're plugging into the rule, we're plugging it into that top thing that we wrote down. And in case you can't look at the top of your paper and see what it is, it's a sub n equals a sub 1 times r to the n minus 1. Now, let's figure out what the common ratio is for this one. Remember, you would do 12 divided by 2, 72 divided by 12, 432 divided by 72. So I want somebody besides Jordan, Jackson, Alexia, Jarek, and Alicia to tell me what it is. You need to be able to divide without people shouting it out. So do 12 divided by 2, 72 divided by 12, 432 divided by 72. Give them just a minute. Ava's going to tell us this one. You can tell us the next one.
Adam has it.
Ava, tell me.
It's divided by 6 each time.
Yeah, you're increasing by 6 each time, right? So then to plug it in, our first term would be what? What's a sub 1? 2 times, what's the common difference? 6 to the n minus 1. Does everybody see how we got that? Alright, so Ashanti is going to tell us the common difference for B. Adam is going to tell us the common difference for C. So start working those out. We're going to write the rule together, but I want you to figure out the pattern.
He said he's doing the common ratio.
Yep.
Three.
Is it 3? Do we agree with 3? Awesome. And Adam's going to tell us for C. Does everybody agree with the rule I wrote down for B? Because you use your first term of -5 and then times your common ratio to the n minus 1. All right, Adam, tell me what you got for the common ratio here. Which is known as what in fraction form? 1/2. Do we agree or disagree? Agree. If you answered any of the questions, take a point. All right, so what is a sub 1 for C? Troy, did you give y'all a point because Ashanti answered? All right, what's the first term on C? 80 times, what's the common ratio here? 1/2 to the n minus 1. Are we ready to find some terms? Let's do this. All right, so for A, I want us to find the 16th term. So we would say A sub 16 equals 2 times 6 to the 16 minus 1. Now, I'm just using my rule, and then I'm plugging in 16 for n. Does everybody see what it did? Okay, now what is 16 minus 1? 15. Then in your calculator, you would do 6 to the 15th power. So 6 caret 15. Everybody do that. I want to see you typing it into your calculator. Oh, that's going to be crazy. And then I want you to multiply it by 2. Did y'all get craziness?
Yeah.
Alright, so to write that, that's scientific notation, right? So that's 9.4 times 10 to the 11th power. 9 point all that, actually. You want me to do it over again?
No, like I know what to do, but I have to hear 9.4.
You do 6 to the 15th, right?
Like how do you know?
I'm going to tell you, and then I multiply it by 2, right?
Yeah.
And then I don't want to write all that
Could you write on it?
Yeah. It'd probably be better to write all that because our term is not 94,000 or million or quadrillion, right? It's all of these numbers, but we don't have room right here. So we could put a star and say C calculator. Let's write that. C calculator. All right. For B, let's find the 8th term. For B, let's find the 8th term. So we're going to do A sub 8 equals negative 5 times 3 to the 8 minus 1. Yes.
What is your calculator on?
Say it to me again.
What is the calculator set on? Like, when mine doesn't show that I'm still good.
What does yours show? Does it say E?
It just doesn't say.
You just needed the magic buzzer. It's right there. It's tiny, so you won't see it as well, but yeah.
I got 18 pounds, right? I have
All right, Jarek is going to tell me, and then Troy's going to check it. Jarek, what did you get?
Negative 10. I mean, not negative 10,000. 95, so 10, 95.
Negative 10,935. Troy, is that what you got?
Yeah, I think it's negative.
Okay. Well, it's negative because it's a negative 5, right? Did anybody else get that? Awesome. Great job. Take a point. All right, for the last one, I want you to find the 13th term. Yep, do it on your own. And when you plug 1/2 into the calculator for your exponent, put 1/2 in parentheses. Great, give everybody a minute. What did we get?
0.01953.
Okay, I can't really, I don't know what y'all muttering at me, so let me plug it in my calculator. I did 1/2 to the 12th power, right? And then I times that by 80. Okay, 0.0195325. Boom! Did anybody else get that? Take a point, children. Great job. Yeah, because it's 13 minus 1. What you're going to do is you're going to start by cutting each of these out. So let's go ahead and cut each of these out real quick.
You don't have to cut the whole line. It's like each way.
I want you to cut each thing out. Alright, so I cut out each of my rectangles, and then I'm going to stack them and cut down the strip so it doesn't take so long. So I suggest you do that too. So like cut them and stack them, and then cut them. Does that make sense? Yes. Yes. You should have 7 total problems, right? So what you're going to do is you're going to line up your sequences on your paper on 17B and C like this, and you're going to glue or tape them down. Then you're going to find the ratio, and you're going to match up the ratio with it, and then you're going to find the rule that goes with it. Does everybody understand? So you're matching them up. And I need us to cut a little faster because we only have 7 minutes left together. And if we don't finish, what do you think this is going to be? Homework.
But if you do finish it, do you have homework again, still?
No.